MOD by 5. What does it mean? This output is either for any number. What about the character? You can change ASCII code. Then one of these. What about the statement, sentence? Can be one of these. You can change ASCII code, whatever you're processing, then apply the modular. So modular is a remainder. Okay? So first hash is starting from the function. Then the most popular one is the modular. Is that only one? No. There are variety of the hash function, but this is a simple and the most popular one. Then the third one, what is the characteristic of this modular function, hash function? Why do you use? Which one is simpler? This one or this one? Input or output? Output is definitely simpler. No matter what size of data you input, modular by 5, 1 of 5, 0 to 4. Okay, which means any complex data will be simple 0, 1, 2, 3, 4. Then what is the benefit? When you search the data, you have the huge amount of data, okay? But first apply the modular by 5. Then your search area will be roughly 20%. Right? The hash is always if the A and B are the same, hash of A is the same as hash of B. That is the idea. Okay? So instead of accessing A and B directly, we can access after applying hash. So that's the 0. Then your search area is narrowed down only the distance. Huge reducing. Just by applying what? Hash function. So usually hash function is a simple. Okay? If you are using very complicated hash function, no, I don't think so. You will not get the benefit. But this one, the modular, so you can narrow down simply 20%. Search area is, so usually hash is used for the searcher managing huge data, but simplify. Then you can speed up. So then at the time, this one is the hash key. So for each hash key, you can manage something space. So any data that belongs to the hash key 0 will be here. Okay, this is called the hash bucket, or sometimes hash file. So this is a hash file, this is a hash bucket. Each one has a hash bucket. So that is the hash table. So we can, when we have FCB, instead of managing a huge number of FCB, separate by applying the hash function FCB1, FCB the 6, FCB11, FCB2, and so on. Okay. The problem is not only the hash table used in the file system problem, but it's the general problem of the hash. That is the collision. What is the collision? So when you purchase the insurance, okay, you need to think about first required one, right? What is that? The name of the policy. You should have mandatory. What is something name of the whatever? So you need to. What is the name of that? The policy insurance. Medicare, not the auto insurance. I mean, you need to have liability. So you should have the liability, and plus collision, right? In case of collision, so you hit the garage by yourself. Then if you have the collision, then it will be insured. So collision is the collision of what? The data in the same key. Because even though 1 and 6 are different, they are not the same, but they are in the same bucket. Okay? That's the collision. Because they are different, they are in the same bucket. So collision. So the more data you have, the bigger size of the hash table. It will take a longer time. So that is because of the collision issues. So to address the collision, there are there are several solutions. So why don't you check the algorithm textbook. okay, that you used in the freshman or the sophomore. So why don't you check it's the same problem. So we can use the hashing. Hashing is always a good solution, usually. It's not the best one, but by applying the simple hash, the function, usually it provides a very good performance. So we can use the directory, use it in the directory implementation. Then we talk about how to implement a file using the fcd and also directory structure. The next thing is I didn't mention about this one. What is this? This is one of the common mistakes when I ask to implement the file system to the student. Student create the file, like the PFS file. That's good. Then, without designing anything, just implement the put command, which means that this is the NTFS files, the host file system. Or if we are using the Linux, it's the EX6 or 8, EXT6 or 8, the extension file system. Doesn't matter, no matter what file system you use. You have the, for example, NTFS C 1.txt file. So you can put command 1.txt, which means this file will be copied to inside your file system, PFS. Just copy 1.txt, and so on. This will not be accepted, okay? Almost a 0 mark. So instead, before you copy this one, when you start your file system, what happened when you purchase the new hard disk drive? You need to format. What is a format? Create the data structure for your new device. So in file system, what kind of data structure we can use? All I/O will be based on what? Blocking. So we are going to use a block to read the data. Even though I'm reading the 1 byte of 1 bit of data, one I/O, the one block will be returned. So all I/O will be based on the block. By the way, why do we need to use the block instead of just bit by bit or byte by byte? Byte we can understand pretty much because 16-bit processing, 32-bit processing, in one cycle, the 16-bit data or the 32-bit data or 64-bit data will be transferred, right? That's the bit processing. Because of that, we are using we love the 64-bit processing the computer. Okay, but what about the blocking? Why do we need to block? I need only 1 byte, but why do I have to return the 512 byte? First, fix the size. It's usually we don't have to worry about too much. Where's the start? Where's the end? Right? Only 1 block, then the return. Another one, even though we read the first 1 byte, mostly we read consequent, the next byte most of the time. So if we upload the 1 block to the memory, next time you don't have to go to the hard disk drive or the secondary storage. Instead, you can just get the data from the memory. So for better performance, similarly, so when you start the PFS, the first job is after you create the nothing empty PFS file, the 10K, you need to format. Even though that is not mentioned in your project description, you need to do the formatting. Formatting means create number of blocks. What is the block size of the PFS? It will be probably 256 byte. It doesn't matter, but for the consistency, so we will use the 256 byte block. Then, how can you format? If I'm asking to implement a formatting, how can you format? Think about designing the city. Have you ever played the SimCity?
Yeah.
You still play? That's funny story. So I have seen the MacBook first time 1995. So really old. My roommate, when I visited, my actually elder sister lives in Hawaii. Looks good. So I visited her the home and stayed I think 6 or 7 months. So, but 2 weeks later, I realized that the Hawaii is one of the horrible place to stay. There's nothing I can do. It's just 2 hours driving around the Oahu, where the Honolulu is. So after 2 weeks, nothing special. So every day I with my friend, usually I drink the street of Waikiki. So why do I mention this one? It's related to something gourmet. Oh yeah, the MacBook. So then I stayed in the dormitory. My roommate used the SimCity. He was in the computer science. He played their interface. First thing that I surprised is the interface of the MacBook. Its Aqua interface is totally different from the Windows 3.1. So it was a shock anyway. So then he used his computer only for SimCity. So SimCity, so I asked him how to play the SimCity. So first you need to create the street, right? So to create your city, first thing is not the building the house or the building the shopping mall or whatever. So first you need to create the road, then utility, and so on. Then the people are getting together and it will be bigger. So same thing, you need to create the road. However, when you design, think about you are the civil engineer. So if you design the city, do you really create the territory or the boundary or this is you just spray the street? No, you don't have to. Just logically, from here to here, this is the main street, and the 10 feet away is the second street, something like that. You can just design. Same thing. Why? So some of the students ask, most of it actually, how do I implement the formatting? You don't have to do anything. Then instead create the one data structure. It's a one-dimensional block. Okay? 0 block is from 0 byte to 255. Number 1, 256, 511. Even do you have to manage this one? No, you don't have to. You can easily calculate location of the block. Block number times 256 minus 1. This is the starting of the block. Nothing you need to implement. Just manage this one with the one later. For what? We will say free space. To see the free space. Okay? In your program, in your mind, you should have that. There's no physical implementation. But when you load the file, 1.txt file, first you need to, this is kind of the resident. First resident to stay in your building. So in the city. Then you need to assign the free block. So let's say the number 1 is number 0 will be used for header information. So this is for the management issue or the town hall. Then this one is free. Number 1 is free. Then you can calculate. Number 1 starting is the 256. 5. Actually, number minus 1. We can calculate this one. 1 number times 256. I think this one. Anyway, you can calculate, right? So then you know the 256 is the starting, it's an offset. So you can just calculate and copy this file. So what not this way? So this is block number 0, block number 1, block number 2. This one is used for the header information. Then your 1.txt file will be copied to the number 1 block. Or if you assign the number 10, and number 10. Number 10 will be times 256, and the offset is the 0. Location will be the copy. How to copy? 5 string. Just use the 5 string. Byte by byte. The copy. That's it. Then update the FCB. Something like that. So this is a formatting. So this is the same. We are pretending the real general file system what's happening. So don't have to create a line on your file. There's nothing you need to do. Just keep your mind how many blocks. But later we will see the how to find the free block. So you need to make the free block. So from the free block you can find the available block. So then next thing is this file is size is the 512 byte. Each block is 256 byte. The one block is not enough. So depending on the how to allocate the block. So there are different ways. One naive way is contiguous block. So for example, how many blocks do you need? 2 blocks. So 2 blocks continue in a row. You need to find. So for example, if you are available only this, so you cannot allocate. Even though you have enough the free block, you can allocate instead until you find the contiguous, the block that is a contiguous allocation. Yes?
What is contiguous?
The continuous, continuously in a row. Okay? They are, for example, number 0, number 1, and number 2, number 3 are contiguous, the block. They are next to each other. Okay? What is the benefit? Simple. Why is it simple? If you know the starting, that's it. You can just calculate the starting. Okay, you don't have to worry about the next block and next block because it's the next block, right? So you can easily calculate using the block size. So that's the contiguous allocation in the project PFS. So you must use the contiguous allocation. Problem? Yes.
When files get deleted, it's simple when it gets added, but when file gets deleted in the middle, then you have fragmentation and wasted free
It's
space.
a fragmentation issue. Have you ever used the Windows 98 or 2000 before? No? What is the oldest version of Windows you use? XP. I think the XP also has. So when you use the old version of Windows, it's from time to time. It's getting slow. So you need to do what? Defragmentation. Defragmentation is the same problem as this one. Because your file is not allocated to the block by block step. We will see such approach. But reasonably some of the blocks are contiguous allocation. So, but even though you have enough space, free space, but they are separated, which is called the fragmentation. You cannot create them. Also, another problem of the fragmentation is performance. You need to go to this one, find this, and all everywhere. It will take a longer time. So, solution? Defragmentation. What is a defragmentation?
Putting all the fragmented
Compact next to each other. So there's a very fancy, nice the graphic while you are doing the defragmentation. So first time when you start the defragmentation, all scatter the color bar, and after compactness or the defragmentation, they put together. So that is the defragmentation. So contiguous allocation has a problem of the defragmentation. So because the fragmentation issue. In the project, you are going to use the contiguous allocation. It's a simple to implement. If you know the starting of the address, you can easily calculate. So this is a diagram for the contiguous allocation. Let's see in this example, the block size from now on the 512 byte is most popular. The block size, I/O block, or even the memory. So it's 512 byte is used a lot. So in this case, 512 byte. So there is a directory structure. Directory is FCB for each file, but it has only the information about the file, start block number, and length. We don't need each block information because they are next to each other, continuous. For example, the one.txt file needs the 3 blocks, like this is 1,000 file. So if we know that this one 256 or the block number 1 block, then how many? Total 3 blocks. Then you can calculate each block is used. So that is the benefit. No matter what size of the file, the block, we can know. For example, the count is starting from the 0. How many? 2. And the list is 28. And how many? 1, 2, 3, 4. So that is the contiguous allocation. Question? Yes.
Oh, in the middle of the blank part, is then the storage cannot find out that that doesn't count as free storage, or can
This one, so for example, 4, 5,
Yes.
8, 9.
Yes.
So what we see, how we can find such the free space. In other words, a free block later. Okay. Right now we are talking about how to use, how to allocate. So first approach is continuous. Her question is, what about the free block? So we will manage that separately. We don't have to read all of this, so it will take a time. Whether this is the free seed or it's like this is a very good example of such a block. So each seed represents the free, the block. So there are some blocks, the free seed. Okay. So from outside, we don't have to search which seeds are available. Just outside, we manage the free. If somebody take that seed, then take out. And if someone leave the class, then put back. So we will see how to manage such a free block. Okay, then another approach is, for example, these 3 students are the close friend each other. Okay, they usually sit together next to each other. Okay, so what you guys want is at least 3 available. Okay, instead of the 1 by 1, so they don't need all the free space allocated, just the small number of continuous, the free block. That is called the extend, the based system. Extend means a fixed number of the contiguous free block. It doesn't have to be all the free block, just for example 3. So I'm going to make instead of the seed by seed by seed, block by block by block, it will take the longer time even. Instead, 1, the extend, 3. And another extend, another extend, another extend. Extend is the a number of the fixed number of the free block. So extend is a continuous block, but not entire, just a fixed number. Okay. This approach is used a lot in the database. Database management system use the extend instead of because the database use also block, but their block size is not the 512 byte. Instead, it's a multiplication of the operating system block, like the 2K, 4K. Sometimes, anyone who took the big data system before? No one? Yes. What is the block size of the Hadoop? It's a 64 megabyte. So which means even though you read 1 byte of data, 64 megabyte will be returned to the memory. So it's a huge. Why do we need to use such a huge size? For better performance. Because eventually we will read all the data in that block, even though we start. That is a big data solution. Okay? So similarly, so extend. Because whenever we read the data, 1 byte of data, pretty much this extend will be used. Also, another benefit of the extension is number of block. The more data you have, the more size. you need to manage the number of blocks. Instead, if you use the certain fixed size of the contiguous block extent, the number of blocks that you need to manage will be reduced. It's a better performance. Okay. The next one is the linked allocation. Linked allocation, let's see the example of this one. So, for example, this is the G file that needs total 5 blocks. So, it has a start, 9. Go to 9. And this block has the link to the next. Next is a 16. So, going to 16. From 16 block, use the block as a data. Then at the end of block, it has a pointer to the next one, 1. And so on, and until -1 is the near, which means no data, but it indicates the end of the file. So this is the linked allocation. So linked allocation to address the problem of the fragmentation of the contiguous allocation. Even though you have enough space, but if they are fragmented, you cannot use it. So instead of the continuous one, so we will So this one is the first block. So your FCB, your directory has the starting. So number 1. And at the end of the block, it has the 10. So you can go to the 10, number 10. And then 5, and at the end of the block, it has the 2. And going to 2. And so on until -1. -1 means it's the end. So you can also manage it. The end of the block in the directory structure. This is the linked allocation. Benefit?
Faster execution.
You can fully utilize the block. It doesn't matter whether it's fragmented or not, you can fully utilize. Problem?
Extra data.
How to extend? You can use this one, then update, find the next block. So you can use the problem. Delete? You can, for example, delete. We no longer need this one and update this one is -1, then update the end. We can do that. Always, when you search read the data, random access is not easy. What about the contiguous? Can you do the random access for the contiguous allocation? You can easily calculate. So you don't have to read each and every block. Instead, you can calculate. So for example, offset of the contiguous. Like for example, this one is the offset is the 600. 600 is the first block or second block. You can divide by 512 byte and floor. That means it's a 1. 1 means second block. Or you can floor than the second block. It doesn't matter. So you can find for example 0. 0 means the 1 means it's a 0, 1. So you can calculate the access directly. Just go by the random access. However, linked allocation, you need to read the first block next until you find the data. Only sequential reading. The problem is the performance. So, and also another small issue. It's not big issue. You cannot fully utilize the 512 byte because you have link next address. Like if you are using 4 byte of the data, so your utilization is around 96%, something like that, or the 92%, something like that. So which is doesn't look like the huge, but when you have the huge, very expensive hard disk drive, it will be a problem, but that's not the big issue. So for example, FAT used this linked allocation. So it in the directory structure starting block and next until the end. Okay. In this case, sometimes we don't have to manage the end of the block. Instead, always we read until the really end. Okay. So That is the F18, the used in the Windows file system. Okay. Because of this reason, the old version of the file system in Windows is suffered from the defragmentation. So they provide fragmentation, so they provide a defragmentation compactness solution. Another approach is the indexed allocation. Indexed allocation is in the directory structure for each file, the point only index block. Then this block is not used for the data, but index. So index means where. So this file has a 9, used 9, 6, 16, 1 in this order. And if not used yet, but allocate -1. So later, if there's the new data, the block will be used. This is not assigned, but in the index structure, there is a space to be increased. If you use all the indexed block, you can allocate another index block. Okay, so in this, the index block, and or the point, it doesn't matter. So suppose that we have the one index block, so 9, 16 to the 25 will be used. So when you access the data, first read the directory block and read the index block, then using the pointer of the data, you can access. For example, 1, 2, 3. Okay. So 1, 2, 3, the method. What about the linked allocation? You need to 1, 2, 3, 4, 5, 6, and so on. And what about the contiguous? Contiguous, you can read the directory block, then calculate the location and directly 1, 2. You can do the random access. Okay. So that is the indexed allocation. You can understand the meaning of that. What if file size is so big, really big? So which means you need multiple indexed block to index all of this, right? Then to search this one, it will take a time. So you need to read all of this. So solution, we can make the index of index is a multi-level index like this one. Index of index. What if this one is so big? We can make another level of index. Index of index of index. So this the indexed allocation and the multi-level index is used a lot in. Have you ever heard about the inode? Inode is the data structure, file system, the data structure, allocation data structure used in Unix file system. So Unix file system, when I use the Unix file system first time, so it's limited by the file size. You can create the file size up to 2 GB in the 16-bit or 32-bit processing. I cannot, even though I purchased the 10 GB hard disk drive, but my file size is limited by the 2 GB. The reason is the Unix file system inode structure. 32-bit is 4 GB because it's designed like this one. They are using, for example, the direct block. Direct block is indexed block. It's a directory. So point the data block. Data